Okay, so today's lesson is we're starting a new chapter, obviously, right? Starting our chapter 8. So our first lesson at chapter 8, okay, on measuring figures, which is a geometry chapter, is talking about something called circumference. All right, so if you haven't done so already, most of you guys have it ready, but I need to see green on the left, notes on the right. So meaning that this should be right behind your, bless you, your vocab, green vocab divider. Okay, here we go. All right, so our very first word, everyone, is the word circle. Everyone?
Circle.
All right, so here's what your book calls a circle. It's the set of all points in a plane that are the same distance from a given point called the center. Okay, very fancy definition. We usually think of a circle as kind of a curved line like that, right? Well, they're stating that you have a center and it's a bunch of dots, points, that are the same distance away from that. So a whole bunch of them that create the circle that are very, 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 very close together. Okay? So that's what they're saying. So here's what all you need to do, guys, is go ahead and write down, draw a circle, and do me a favor, put the center in there. That's going to be, you're going to find that's an important part of today's vocab. You're going to see that word almost in all of the vocabulary. All right, so our next word is exactly what I just said, the word center, everyone.
Center.
All right, so here's what they're talking about. It says, this is the point from which all points on the circle are the same distance. So it's kind of like the last vocab, but it's kind of flip-flopped. Looked at it from the opposite angle, opposite view. The point from which all the points on the circle are the same distance. So here's what I want you to do. Go ahead, again, in your little box, draw a circle, put a little dot for the center, but point an arrow at it, okay, because that's what it's talking about. Okay, and our next word is circumference. Everyone? Let's try that one more time. Circumference, everyone? All right, so this obviously is the whole idea of our lesson today, right? It's what our lesson is called. This is the distance around the circle. The distance around the circle. Now, the synonym to this, all right, would be something like perimeter. It's not the exact same meaning, but it is very similar, and that's why it's a synonym. So, usually on a polygon, like figures that have straight sides, you'd find the length around the outside would be called the perimeter. But with a circle, it's curved side, so it's just referred to as a circumference. All right? We're going to keep going. Here we go. Our next word is diameter. Everyone? Diameter. All right, so this is the distance across the circle through its center. The distance across the circle through its center. So here's what I want you to write down. That right there. So go ahead in your little box, draw a circle, draw the center. But this one is a line that goes from one side to the other, but it passes right through the center. That's what a diameter looks like. Okay, and then our next word is radius. Everyone?
Radius.
So here's what the book says a radius is. It's the distance from the center of the circle to any point on the circle. So one more time, the radius is the distance from the center of the circle to any point on the circle. So for example, a radius would look something like that. All right, so let's just draw a quick conclusion, even though it doesn't say this. since these nice little diagrams are here, what can we say if, as long as it's the same circle, okay, our congruent size circle, right? One that's the same size. How can we describe the radius in relation to the diameter? Or I should say, how long is the radius compared to the diameter? Or the diameter compared to the radius? How can we describe it?
The radius is half of the diameter?
The radius is half of the diameter. So the radius is equal to 1/2 of the diameter. The other way you can think about it is the diameter is 2 times the radius, or double the radius. Okay, so just a couple of things to remember. Okay, there is a relationship between the two. We'll talk about that more in just a bit when we take a look at a problem. Okay, I do have a little bit of story time for you in today's lesson. So, here we go. All right, so what we know is, and by the way, the story is a little bit of, we'll call it historical fiction. Okay, so it's a little bit of history about math, but a little bit of fiction to it. But here is what I want to talk about. Now, if you remember right, at the end of the first semester, we watched that nice little Disney video, right? Donald in Math Magic Land. It kind of was, something that Walt Disney came up with to describe a little bit of, in there was a little bit of history of math, okay? And so, like it described in there when it talked, especially like about the people playing the music and everything else, if you remember that, is that math is everywhere, but more importantly, math came from somewhere, all right? People discover the things that we learn nowadays. It was originally discovered. Some of the patterns and things involved in math. All right. So back in the day, right, and you talk about back in a place like ancient Greece. All right. There were people that instead of getting on their PS4s at the time, all right, they ended up loving to experiment with math, with patterns, with things that they could discover. And so back in those days, you've seen ancient Greece and the parts that were, are still there, and the buildings and things. I mean, they use math in all of those things. Now, at the time, though, you could discover the length of a straight line. So, for example, the edge of that paper right there, they had tools that could be able to measure that. Things like that, right? Nice and easy, all right? However, the issue was what if you don't have a nice straight edge? What if you have something like that? If you have a circle? And so they struggled a little bit about that. And so what they did was they kind of experimented. They talked about it. And I mean, granted, you could use a straight edge tool and try to find, but you're just going to get an estimate. It's not going to be overly accurate. But they wanted something that was way more accurate than something like this, all right, as a tool. So here's what they did, is that one person in ancient Greece turned around and they drew what we just talked about, the diameter of the circle. And what they did is they took another tool that was the exact length of the diameter, one, though, that can bend. And so what they did is they took that circle and they cut the length of the diameter, and they took that tool and they wrapped it around the circle. And what they realized is that this diameter, it takes 1, 2, 3 of them to go around this. However, they were still a little short, just a little bit. And I said, well, that's interesting. But what they wanted to see is they wanted to experiment with some more, right? I mean, that's interesting, but you want to keep going and going and to see if they can find any patterns with this. Well, they, of course, then in turn got a second circle, one that was a little larger. And what they did was they turned around and they took the diameter of that circle, not of the other one, of that particular circle. And they did the exact same thing. They took that tool that was the length of that diameter and realized that the diameter, it took 1, 2, 3 of these to go around the outside, but then again, still a little left over. That's interesting. But any two things could be a coincidence. So what do? They tried a third one. And again, they took the diameter of that circle. And again, you guys get the idea. They wrapped it around the outside. And they realized that 1, 2, 3 of those diameters went around the outside with a little left over. Now here comes the interesting part, is that little left over, that little bit left over, they realize, taking a look at all of these diameters, the little bit that was left over on each circle actually ended up being exactly, or about, I should say, 1/7 of this diameter. So basically that part right there, it took 7 of them to make up this tool. 1/7. So what they realized is that the diameter, it took 3 1/7 of the diameter to go around the outside of the circle on every single circle. Well, what they did, of course, is they calculated it and they converted that. They played with that number a little bit, and they took that 1/7 there, and 1 divided by 7, they converted it to a decimal. And here's what comes out. 0.142857143. So what they did is what many people do nowadays, is they rounded it to just 0.14. The ancient Greeks have a number and a symbol system. And back then, they gave this number, this special number for a circle, a special sign. And that sign looked a little like that. Which we know this sign now to be called pi. And therefore the discovery of pi happened. It is the amount of times the diameter goes, or how many diameters it takes to go around the outside of any circle. All right? So, what we want to take a look at is, let's take a look at this last vocab word. And that vocab word is the word pi. Everyone?
Pi.
So, here's what they say pi is. The book says it's the ratio of the circumference of a circle to its diameter. The book goes on to say the Greek letter pi, and that's just kind of the font that it shows as pi, represents the number. The value of pi is, and they state it as 3.14159, ... meaning, guys, this is an irrational number. It actually goes on forever. And it turns around and says approximations, meaning that rounded guesses for pi, what we use are 3.14 and 22/7. Say, well, Mr. Wilkins, where'd that one come from? Well,
What's
3 1/7. 7 times 3 is 21, plus 1 is 22. All it is the improper fraction form of 3 1/7. They put these two in the vocab because these two are, when you calculate numbers, those are the two that are easier to use. You'll have to change 3 1/7 to 22/7 anyway. So in your little box there, go ahead and just write. And this is just kind of weird looking. Pi is usually more of a curved line with 2 legs like that. So in your little box there, you can write the symbol pi. Okay, so here's what we're going to do. Let's go ahead, let's grab our book, and flip your book over to page 616. 616. 616. All right, eyes up here when you're ready. All right, here we go. So let's take a look at problem number 2 on 616. Page 616. So here we go. The directions, ladies and gentlemen, are very important. It says find the radius or diameter of each circle with the given dimension. So for example, if you take a look at number 2, here's what number 2 says. R equals 14 feet. Now listen, we'll call this step star because it's more mental math. I'll make a little like brain here. All right, it's an ugly brain, but you see it. All right. In here, here's what you definitely need to think about. Think about what exactly that is saying. It is saying that the radius, be careful, radius and diameter are two different things. The radius is 14 feet. Now also remember that what we talked about earlier, right, is that the radius is the same as 1/2 of the diameter. Or you could say the diameter is equal to the radius times 2. Double the radius, or radius plus the radius. So, what that means is, since this is step 1, since this is the radius, I'm going to figure out the diameter. Now, with this one, it's not that hard, ladies and gentlemen. The radius is 1/2, so I would just say in my mind 14 times 2, or 14 plus 14. What's the diameter, everyone? 28. Now, step 2, put our units on there. We're not squaring it, it's not area or anything. Today we're just talking about the circumference and length of lines. So our answer is 28 feet. So for those type of problems, that's all they want you to do. If, of course, they give you the diameter, they want you to cut it in half and say what the radius is. Okay? So that is problem number 2 on page 616, or all the problems like that. That's how you'll solve them. All right, so what I want to do is now let's take a look on page 616 at problem number 5. Now, we're not going to worry about the estimation today. Okay, estimation means that you can get a good idea just by multiplying the diameter by 3 to give you an idea of what it would be. But if you take a look on page 616 at problem number 5, there is a circle, and that circle shows a line from the diameter out to the edge, which obviously is the radius. And the radius is 7 yards. So what I would do is I'd say step 1, draw your diagram if you need to. Okay? Now in this case, I'll make this maybe step star because we don't need to. It's already in your book. Okay? We'll get back to that in a bit. Now, what I can now call step 1 is let's write down the formula, because if you take a look, the directions say find the circumference of each circle, use 3.14 or 22/7 for pi. Round to the nearest tenth if necessary. So here's what I'm going to do. We're going to actually write the formula to a circumference. Here's how you find circumference. Circumference is the diameter times pi, right? You take the diameter, the length of the diameter, multiply it with 3 1/7, because that's how long the circumference is. So now step 2, should be pretty easy. In this case, we need to find out what the circumference is. Now I'm just plugging in the numbers. Now I'm going to put a little star by step 2, because you have to be careful because of the last problem we just did. This is calling for the diameter. Ladies and gentlemen, do we plug in a 7? No, that's the radius. Don't plug in a 7. You'll get the wrong answer. The diameter isn't 7. What is it? It's 14. Now we have a choice when we plug in pi. We can use 3.14 or 22/7. Now many of us will probably want to use 3.14 because we like decimals better. Here's what I would recommend. If this number here is divisible by 7, use 22/7. Let me show you why. Your life is going to be a lot easier. Look how easy this is. Step 3 is I'm going to solve it. I multiply these two, and look at this. 14 and 7 I can cross reduce, both by 7. So 14 divided by 7 is 2. 7 divided by 7 is 1. And now the multiplication is easy. 2 times 22 is 44. 1 times 1 is 1. I'm going to clean this up a little bit and say the circumference is 44. And then step 4 comes in handy. Don't forget your units. In this case, 44 yards. And if you need to, don't forget to round to the nearest tenth. That one we don't have to round. So your formula, plug the numbers in and solve. Now there is a challenge type of problem. Let's take a look at page 617, number 17. I'm sorry, number 7. Okay, here we go. Number 7 says, the largest tree in the world by volume is in Sequoia National Park, which is interesting since it's not too far from us. The diameter at the base is 36 feet. If a person with outstretched arms can reach 6 feet, how many people would it take to reach around the base of the tree? Now, it's a little word problem. It's kind of a little extra twist to it. So I'm going to walk you through this. Okay, step 1 is what I was talking about earlier. We're going to go ahead and draw a diagram for a word problem. Why? Because sometimes if we simplify it as a picture, it'll help us. It says the diameter of the base of this tree, because trees are circles, is 36 feet. That's what it's talking about, 36 feet. Okay? Step 2 is I'm going to solve for the circumference. So I'm going to write my formula. Circumference is diameter times pi. I'm going to plug in our numbers. The diameter is 36. Now that is not divisible by 7, so I'm going to plug in 3.14 for pi. So when I go to solve that, I'm just going to use my calculator. 36 times 3.14 equals, and the circumference is 113 and 400, so 0.04 feet. That's how far it is around the outside. Now that's only the circumference. They are asking us, though, if a person with outstretched arms can reach 6 feet, how many people would it take to reach around the base of the tree? So if I'm doing this on my diagram, watch this. There's the first person that's 6 feet. Here's the second person that's 6 feet. The next person comes in with their outstretched arms. They're 6 feet. Dot, dot, dot. It's kind of like the bar diagram. Guess what I'm doing? I'm taking the circumference, and this is all part of step 3, everyone, which is 113 and 400 feet. And I am splitting it up, or better yet in math, known as dividing it into 6-foot sections. So I take 113.04, divide by 6, and I get 18.84. Now don't put feet, because each of these 6-foot sections are actual people. So my units, guys, are people. Now here's the problem with this. You don't have, I don't know about you guys, but I haven't seen a 0.84 of a person, right? That means there's a little bit extra left over. So that means that it's a little more than 18 people. The answer, of course, is 19 people. And that would be how you'd solve one of those challenge problems.